Okay, check.
Okay.
Looks that we are live. Welcome to the room 404, probably the best room around here. And my name is Jarek Łukov, and I'm a DevOps guy at CodyLime. We are doing services and consulting, and we are based in Warsaw, in Poland. And this is?
I am Pavel, and I'm most likely developer, but kind of moving to DevOps because I'm working with the Ansible, Terraform, and other ops project. And today we are planning to share with you our experience about profiling and optimizing container image building.
Okay, so why we are here. We're going to show you some new build tools that are around that are meant to replace the standard Docker build command. And this talk has a little bit of a human touch, except for just talking about the tools, because there is a backing story about this. And since we are on a conference that is emphasizing openness and collaboration, this is also going to be a talk about many people collaborating on the same project and agreeing on what's important for them. And we will focus on caring about the performance and how to make people care about pipeline build times that are shared between all the developers. And we'll face some problems with performance tracking and enforcing the performance. And in the context of containers which introduce new kinds of opacity into the build process, because right now all the things that we are previously been doing outside of the containers now are performed inside some new enclosure. And we need new tools for profiling this and for debugging this. And the talk will be divided into 3 parts. First, we'll briefly go about the build tools. 2018 was a year when a couple of new things emerged. So we will not going to mention much details about this, but we are going to focus on not how the builds are working, but how we can use them for our greater good. Then we'll show some developer use cases, so how people that are developers and people who are contributing to software projects can use them to get some more insight into the build process and how to make it easier for them. And then we'll go from the small scale to larger scale and how to integrate these tools into CI process and CI pipelines. And okay, Pavel, go ahead with a summary of the build tools.
Building tools. So we have simple, good, and old Docker builds. So it's really good to small image, and it's really little worse for more complicated builds, because it's do everything that you telling to it, but nothing more, nothing less. And it's builds image from the top to bottom. What I mean from top to bottom. For example, we have on the left side, we have Dockerfile with the 3 stages. And on the right side, we see the output that every of these stages was built. And as you can see, second stage doesn't matter for the final image, but still Docker build made it for us. So we kind of losing some performance of this image. Next tool is BuildKit. Was made by Moby and integrated with the Docker in 90.0. And you can very easily use it, just typing Docker build =1, then Docker build, and it's will work fine for you. What feature they add to BuildKit? First of all, they add new syntax. So you don't need to use Dockerfile. You can create another output like Docker image, tar or OCI. And of course, they add mount. I think this is the best feature they create. So you don't need to more copy your code, then build code, then remove the code from the image. And you can squash it to one layer, just binding the file, build it in the one layer, and just like forget about this, because it will be removed in the next layer. So going back to our example, as you can see, this is the output of the Docker BuildKit build for the same Docker file. As you can see, just like the Docker BuildKit, just building from the bottom to top. So it's checking what's the final layer is and going up, checking the dependency. So in the previous, we see that second layer doesn't matter. So BuildKit just skip it because it's checked that no one used it. So I don't need to use that. And there is IMG. IMG is just BuildKit, but allows you to building without root privilege. So that's, as far as I know, it's matter in the few projects with the Kubernetes. So there, of course, Canico.
So another one is Canico. It was created by Google, and its main goal is to provide unprivileged builds for building images inside Kubernetes containers, for example. And it doesn't create any nested containers. Everything runs in user space without namespacing. And it's Dockerfile only. And yes, its main like target is the Google Kubernetes platform. And Builda. This one is a daemonless. It always also provides rootless builds, which are like not the particular interest of our today's talk, but that's one of the features. And what's interesting, it provides selective squashing. So while we can, it's very common for people to write very long run commands in Docker files and to connect the commands with double ampersands to have the many commands executed in the same layer, so to save space, for example, so we can install a package, and then at the end we can remove the package manager cache, for example. And in Builda, we can run a couple of commands and commit only only in the moment when we want to create a layer, and this can be useful for some storage optimizations. And yes, and about storage optimizations,
yes.
This is one of the tools.
This is not a build tool. This is a tool that help you explore image you build. And it has TUI. So you can just open your image using dive. And then you can check it which layer, what made the difference between the other layer. So what file was added, what file modified it, or unmodified it, or remove it. And it can calculate image efficiency about the storage. I think the funniest one, they add the CI integration. So you can easily add this to your CI, just set up in the set of rules, what efficiency you expect, if it should fail or not, or just warning the user that this image lose the efficiency after you change the commit or change the Dockerfile, something like this.
Basically, you can think about it as a midnight commander for layers. So you can select the layer you want to inspect, and then you can list the files that have changed. This is very, very cool to see what's happening in the layers, but not always we are able to like optimize it. But
yes,
it's very insightful.
Yes, it's not always easy to investigate this, the layer between what file you should remove or what file you shouldn't remove. Another tool is Dockerviz. Dockerviz shows you the tree of your layer, and it's really a small project, but it could be very helpful. So as you can see on this, on the left side, we have the Docker story. That it mean like layers of the Dockerfile I showed before. This image was built by just Docker build, and on the right branch you have image that was built by BuildKit. So you see the difference between the BuildKit and Docker build. Just BuildKit squash everything to one layer. If it's easy, probably for them, so it's squash it. And you don't have another layer, you don't lose the storage performance. So developer use experience.
Okay, so this was a short skip over the new build tools. And now, how do we want to use them, provide them for the developers? So from my perspective, as an operator of a CI system for a project, I would like to provide the users means to like develop the software with the best quality, and I want to make it possibly the easiest for them to use it. So it's not like only giving pointers to tools that they can use, but also showing them how to integrate with our code base, how to use them in their own workspace, and how to analyze the results when they are running the tests in the CI. This is like a story about many different metrics in CI which you can gather, and not only container builds, but container builds are the most appealing for me because we can see container builds everywhere. For example, if you focus on providing some kind of debugging profiling platform for a single framework or language, then it may have less users than when we focus on container builds, which are probably in the majority of projects that we are running. So we have like big coverage, and this may be useful for many people. And it's also, from my point of view, when the CI pipelines, CI jobs start to bloat, when they start to take much more time, it's good to give people tools that can show how much their change is going to impact the overall pipeline time, for example. Because this is nothing wrong that people focus on the features that they're going to implement in their work, but if we provide the visibility and if we into performance, if we show what is important for us and make it also important for people that are like many independent developers contributing to our projects, then we can make people care about the performance, and it's not like realizing after a couple of months or a year that our optimized pipelines are now taking so much time that it's like impossible to work. But we can have the like maintenance of performance distributed along many contributors. So making this hassle-free is like it may give many profits for us as CI operators and as the project as overall. And so we will divide it into two kinds. So performance in terms of storage taken by containers. This will influence the resources that we need to keep our builds in our system. Also the time that's needed to transfer and upload the images to registries. And then the build times that will affect the storage, the pipeline runtime.
Okay, we have first example, and we thought that the best example using Dive, we will be creating the Docker with the Dive inside. So we prepare a Dockerfile with this slim dev OS, and of course we update. We download dependency, then we download the package for Debian, and we install it, and then we remove it. So next, what we do, we just open the Dive with this image, and we check that efficiency have like 93%. So now we can check it which layer have the problem and what file what file probably wasted our memory and we see that we don't need this a lot of layers because every of these layers are connected to the one packet. So we of course can squash it to one layer. It's normal. Probably you see a lot of such stuff like connecting to the one layer, but currently it's a good approach. But of course, new build tools help you with that. Build kits have good feature for that. You can squash it even, and it's look even better. But for now, we're just using Docker build. So after we squash it, we see that the image efficiency going up to 98%. So in this simple example, we see that we can very easily using these smart tools, we can create better image for us. And if, of course, this example is not shows a lot of advantage of this, but if this image is base image and we're using this image to building every other image, for example, we have, I don't know, 100 or 2,000 image, and every image have losing few megabytes or 100 megabytes or something like this, we're just losing gigabytes. And if you're building this twice a day or once per day, we're losing a lot of memory, and we're losing a lot of time because it takes more time, of course. And going forward, this is about layer timing.
Okay, so next simple but very useful example is about extracting layer build times from the build process. And usually when using the standard Docker build command, we don't see how much time it took for every command to execute. But using the new tools, we can get some insight. And as an example, we are using the build kit, which in one of its output modes provides us the information about runtime of each layer. And what we've done is we wrote a very simple parser for the build kit output. Unfortunately, it doesn't provide other formats of output. So, for example, there is no option to have the output in JSON or something. But the software is like a really complicated in the backend. So I guess that the front-end features may come later. And parsing the build times and providing the output to the person that runs the job may inspire to think about what can be improved. At least when I see a list of layers, for example, and I can see that most of them finished in 1-2 seconds and one of them took 5 minutes, it automatically makes me think there's there's something to optimize, why this one long layer can be also shortened. Maybe I can do something to make them more equal. And this makes me think automatically how to try to make things better. And so the usual case that I saw in many projects is that ultimately we are using some kind of a Dockerfile at the bottom, but then we have some kind of a wrapper. I called it make, but it's maybe any other build tool or even a shell script. And then going a little bit further, maybe into the topic of integration with CI, we usually have some kind of code that is running this make in a CI system, but the make step is a good place to inject something that will make the build process more user-friendly. And using the free tools BuildKit, the BuildKit parser, and dive that gives us a JSON. One of the options is to give a JSON output with the information about the storage efficiency. We can amend our wrapper script to display useful information. So in this case, it's a sorted list of layers sorted by the runtime. So on the top, we have the one that took the most time. And we also have information about the storage efficiency of the image and how much storage has been wasted. So for example, how many files were overridden in the layers of the image. And based on this, it's very easy to check how changes introduced to the code improved or decreased the performance of the build for the person that is running the build in their own workspace, for example. And this is an example of how we can provide the information, how we can use these tools in the developer environment. And then let's go a little bit further and see what we can do with the information in the larger scale in the CI system. And so the goal is to track performance and to react to big changes that can be introduced by pull requests that change our performance. Ideally, it will be enforcing performance. So like Dive has this option to fail when the storage performance is lower than specified value. But for the beginning, I think that it may be a little bit too aggressive to make CI jobs fail because of the storage efficiency of a Docker image. So it's better to first introduce some kind of visibility to the process and then gradually introduce some enforcement rules. And next question is where to gather data from. So when we are gathering performance data from CI testing jobs, it may sometimes we are catching values that were created by code that was not merged, that contained errors. So it's not always we need to think about what are the sources of the data, and the good solution would be to use some kind of a nightly job, for example, that always runs on the tip of the master branch, for example. And in our use case, we are contributing to the Tungsten Fabric project, and we have around 60 containers built from around 30 repos. The deployment architecture of the project is similar to OpenStack Cola, so it's entirely container-based. And the situation is that all the repos, and there's no strict distinction between which repos are used in which container. So in fact, every review, every change to the projects can impact build performance in different containers. And it's also important, it will be important later, that we are using Zuul as a CI system. And we want to show you some examples of analyzing the performance in our project. Collecting CI trends in general, it may be used to track metrics from other things than container builds. First we need to generate the stats. We need to collect them, load them into a database, and possibly generate some dashboards and analysis. And in this case, we are using build kit in the Zuul jobs that are running for our repos. We are crawling the logs from the Zuul jobs. We are putting the data into the Elasticsearch database, and we are generating dashboards using Kibana. It's like, these are example tools. I really like them. They really give me the exact complexity level that I need to perform the visualization I need. But they are just an example, and I don't say that they are the only ones that you can use. And once we have the data, we are interested into finding the worst performing elements that we are analyzing, and also detect degradation with time and with new contributions. So this is a graph of most of the containers that are built in our project, and the bars show the runtime of each container built. So we can see that most of the containers run for like some of them run for a couple of seconds, some of them even 0 seconds. So for example, they can be just labeled images that were built before, and this is everything is cached. And then we have a few ones that are like taking much more time than the rest. So let's focus on them. These are the 10 longest builds in CI, 10 longest container builds. And we can use the tool that was previously showing the layer build times, and we can produce a machine-readable output and feed it into the database. So right now we can see a drill down into layers. So the previous graph showed the total build time, and right now we can see how much each layer took. The colors are not important, are not relevant, but they just show the different build times for each layer. And we can see that the first image is not that good for analysis, but we'll focus on the second one. And we can see that there is a single layer that contributes most to the build time in this image. And if we see what's the command, then we again have the situation when a lot of commands were stacked into one layer of Dockerfile, and it's pretty hard to see what's happening inside and what took the most time. But we are now not afraid to split the command into layers, because we know that there are tools like Builda, for example, that can squeeze the layers for us. So we can do this and adapt to our new visualization style. And with this, we can get like more analysis of the build process. And right now we have a layer drill down like a level deeper, and we can see that there are 2 layers that are now like the cause of the whole build time. And apparently these are the longest layer is an installation of Ubuntu packages. And it turns out that most of the container images built in our system are CentOS based. And we prepared a base image that is configured with package mirrors, YAM package mirrors in our CI. But this is one of the 2 containers that are using Ubuntu as a base image. And Ubuntu base image is not customized, and it like connects to the public archives, public package archives. So in this case, the solution for shortening the time will be to provide also a mean to use local package mirrors But this also shows how it's sometimes it's difficult to provide a platform that is usable for everybody. So for example, we can optimize for CentOS and for Ubuntu, but then comes somebody that really wants to build something on Alpine base image, for example, and this may be hard to give a good service for everybody.
Yes, and I've come back. In second layer, the longest second layer is the copy, just like copying the code to the image. And when you use BuildKit, you can use mount and mount this directory, and probably it will take like 0 time just mounting this, and we just taking like a lot of time, just reducing the time of building, just using the new feature of the BuildKit.
And okay, so this was this showed an example of looking into the worst performance in our system. But then it's like a summary and aggregation of data from a period of time. And now we would like to also see how the performance changed over time. So as I said before, we can use data from CI testing jobs, but this can be a little bit misleading. This gives us the most data because there are like the biggest number of jobs are the CI testing jobs, which are like usually called checks among the Zuul users. But we will measure the tests that were run also with code that is not ready for merging. So for example, the code had errors. The execution took a very long time and the job timed out. So we are also gathering those statistics. It may be risky. So we can think about using maybe only final patch sets of the change. So if there is in the Gerrit nomenclature, this is the final patch set, but in the GitHub pull request, for example, we can take only the last commit from the branch that we are going to merge into our target branch, and this will give us a little bit more precise results. But still, when we are running the CI testing jobs, we are not running them inside the final state of the repo when they are going to be merged after review. So this is like closer, but not 100% perfect true performance analysis. Then we can think about running performance analysis periodically. So like every 24 hours, we can run the analysis for the tip of the branch, and then we can get statistics out of it, and it's very good. But we don't have results for every commit that is going into the repo. And then, surprisingly, we have a side effect of one of the like the best features of Zuul, which is gating. And in Zuul, for every merged change, we are having a gating job being executed, and we are sure that this job was run in the exact state of the repo that is going to be in the branch after the change is merged. So we have exact results for every commit that is going to our repo that we are maintaining, and this is very nice because it gives us, as a side effect of this feature, we are getting a strict ordering of commits among different projects. And this is important if in our situation, for example, when we have multiple projects, multiple Git repos, influencing the build performance of many containers. And here we can, having this commit history and the performance stats out of every commit, we can see exactly which commit introduced a change in the performance. And this looks like this. So we have two projects that are independent on each other, and when we are running jobs, we are using both of them in the Git workspace for executing the tests. And Zuul gating gives us ordering, and so that we are sure that the jobs for the change A1 were run before B1, and for example, B2 was executed having all the previous commits in the workspace. So we are sure that we are having the exact timings and results. And having this, we can draw a timing graph of a single container build, for example, and we have this labeled by the commit ID. So if we have a sudden spike and in the build time, we can pinpoint exactly the change that was responsible for this change. And the strict commit ordering is something that we are sure that it exists, but it's not directly available. So we are using just the SQL database that is used by Zuul to record its job results, and we are just using the ID numbers of the primary key to detect the order of the changes entering the gate pipeline. And other important thing is that when we want to draw a graph that is indexed by the changes, it's important to include only changes that are members of one gate queue, because only those projects are interdependent on each other. So this is something that is not yet solved, but fortunately in our projects, most of the repos are in the same gate queue, so this is not a big issue for us. Okay, the summary.
Final thoughts. So final thoughts. BuildKit is strictly better than Docker build, so update Docker, use BuildKit, and add your checks about your image in CI. I mean, storage and timing, it will be the best option. You can, like Jarek said, you can create the graph about the timing. And if you are developers, learn about your jobs in the CI. And if you are ops, teach your developers about the CI and teach them how can use it in locally, because we saw many times that developers rerun a few times the same commit, thinking that there is problem in the CI, and just after a few retry, checking the outputs of the CI and checking what was the wrong. And most of the time was some typo or something like this. And I think that's all. So thank you for having us here. And this is some few examples that we don't tell about, but you can check it by yourself, or you can find us and ask about this. And tribute to people that made a few of the tools. And if you have questions, I don't know if we have time. Like probably we not a lot. If not, just find us on the hall and ask us.
Yeah, there's one more slide. Only one more slide. Everything that we wrote, so the build kit output parsers and uploaders to the Elasticsearch database. Unfortunately, not the Kibana dashboards, but everything that brings the data up to Elasticsearch is available in our Git repo. Okay, thanks you for coming. In case you have any questions now or later, please come.